I want you to imagine for a second that you possess a superpower.
Okay, I'm listening.
But it's a very specific and honestly slightly overwhelming superpower. Imagine you can suddenly see every single wireless signal in the room with you right now.
Oh man, it would be blinding.
Right.
Yeah, I mean, absolute visual chaos. You wouldn't even be able to see the walls for all the electromagnetic waves bouncing around.
Total sensory overload.
Yeah.
I mean, you've got the Wi-Fi router broadcasting at your laptop.
Yeah.
Your phone is pinging the nearest cell tower every few seconds.
And your Bluetooth earbuds are constantly shaking hands with your smartwatch.
Exactly. It would look like a densely packed room where literally every single person is shouting at the top of their lungs, completely ignoring everyone else, just trying to force their message through the noise.
And we just walk right through that invisible crossfire, completely oblivious.
We really do.
We expect all those unseen conversations to happen perfectly, without any interruption, millions of times a day,
Yeah.
just so a web page loads or a text message goes through.
Right up until they don't.
Exactly.
And that invisible chaos is exactly what we're wading into for today's deep dive. We are looking at a single, highly concentrated technological innovation called TMA's Passive Directivity Enhancement Technology.
Which is a bit of a mouthful, but
It is a mouthful.
yeah.
But our goal today is to figure out how this one concept fundamentally alters that invisible room of screaming signals we just talked about.
Right.
And more importantly, how it bridges the gap between literal life or death medical interventions and the daily frustration of a buffering home internet connection.
Yeah, because while the notes we're looking at today are brief, they represent a massive structural shift in how we manage the physical waves that connect our modern world.
Yeah.
We're looking at an engineering approach that forces us to basically rethink the integrity of wireless communication from the ground up.
Okay, let's unpack this because my eyes immediately locked onto the highest stakes application here. We aren't just talking about making sure a 4K video streams smoothly. The notes specifically highlight that TMA's passive directivity enhancement technology improves the stability of medical wireless systems.
Yes.
And specifically, it is utilized to stabilize wireless pacemaker systems to save lives.
That is absolutely the most critical application we are examining today, and it fundamentally changes how we need to view wireless reliability.
It reorients the entire conversation. Like if my Bluetooth headphones drop their connection while I'm on a run,
Right,
I just tap the earbud, it reconnects, I keep jogging. It's, a minor inconvenience.
Yeah, exactly.
But when we talk about a wireless pacemaker, we mean a device implanted inside a human chest cavity that's communicating vital biometric data to an external receiver. So stability isn't a luxury feature there. A dropped connection is a medical emergency. Am I getting that right?
You are. What's fascinating here is how the physical environment of a hospital is uniquely hostile to the very signals those pacemakers rely on.
Really? How so?
Well, to understand why TMA's technology is necessary to, literally save lives, we have to look at the physics of a critical care ward.
It's essentially the worst possible place to rely on a radio frequency, right?
Oh, absolutely.
Because you have thick concrete walls, lead-lined imaging rooms, massive pieces of equipment like MRI machines.
Generating intense magnetic fields, yes, it is an electromagnetic nightmare.
Wow.
And then on top of that, you have hundreds of competing telemetry monitors, IV pumps, and staff devices, all broadcasting simultaneously.
So it's that crowded room of people shouting again, but the stakes are life and death.
Precisely. Plus, we haven't even mentioned the patients themselves. Human bodies are essentially large bags of salt water.
Bags of salt water.
Basically. And salt water is excellent at absorbing and degrading radio frequencies.
Oh, wow. I never thought about that.
So when a wireless pacemaker attempts to send a data packet, perhaps a critical alert about an irregular heartbeat, that signal has to navigate through human tissue. Then it has to bounce around metal cabinets and compete with the massive baseline level of electronic noise already present in the room.
So a standard wireless signal in that environment is going to suffer from what engineers call multipath interference, right?
Yes, exactly.
Like the signal bounces off the steel door, reflects off the ceiling, and the different parts of it arrive at the receiver at slightly different times.
And that completely corrupts the data packet. That is the core vulnerability.
That sounds terrifying for a medical device.
It is. I mean, in consumer tech, when multipath interference corrupts a packet, your device just asks the router to send it again.
Right. You get a little buffering wheel.
You experience a few milliseconds of lag. But in a wireless pacemaker system, That latency could mean missing a critical arrhythmia.
Wow.
The data must arrive intact, on time, every single time.
Which means the foundation of wireless medicine relies entirely on somehow overcoming that incredibly hostile physical environment.
Right. And passive directivity enhancement acts as that structural fix.
Okay, how does it actually do that?
Well, instead of broadcasting a signal out in all directions and just hoping it survives the journey,
Like shouting into the crowded room.
exactly. Instead of that, this technology enhances the directivity of the signal. It creates a highly stable, highly focused path between the pacemaker and the receiver.
So it's like a laser beam instead of a light bulb.
That's a great analogy.
Yeah.
It isolates the critical data from the surrounding chaos. By improving the stability of these systems, it provides the foundational layer of reliability that makes remote cardiac monitoring structurally viable in the first place.
Okay, I get this for a pacemaker. The stakes totally justify the engineering. But if we shift gears here, the source material also mentions this has applications for our daily internet.
It does.
And applying this to my home Wi-Fi feels a bit like using a sledgehammer to crack a nut.
I can see why you'd think that.
Like, the notes say the technology also reduces interference between standard wireless systems, improving the overall effectiveness of things like home Wi-Fi networks. I kind of have to push back here.
Go for it.
Are our home networks really suffering from the same core physics problem that a pacemaker faces in an ICU? Is it actually that bad?
They absolutely are.
Really?
Yeah. The physics of electromagnetic interference, they don't care about the urgency of the data being transmitted.
Right. The universe doesn't know it's a pacemaker.
Exactly. A radio wave is a radio wave. The environment in your living room might not have an MRI machine, but the spectrum is just as congested.
Here's where it gets really interesting. You're saying my router dropping my video call is fundamentally the identical technological disease as a medical device losing its connection.
Yes. The symptom is different, a dropped Zoom call versus a medical crisis. But the underlying physical phenomenon is identical.
That's wild.
The disease is overlapping sine waves causing destructive interference.
Okay, break that down for me.
Let's elevate this beyond the idea of a crowded room. Think about how a radio frequency actually works in the air.
Okay.
Your router transmits data by encoding it into physical waves of electromagnetic energy.
Right, and those waves travel through the air to the antenna in my laptop.
But your neighbor's router is also generating waves on a nearly identical frequency.
Oh, right, because we all live so close together now.
And your smart TV is doing the same thing. And the smart fridge, when those distinct physical waves intersect in the airspace of your living room, their amplitudes combine.
Okay.
So if the peak of your router's wave aligns perfectly with the trough of your neighbor's wave, they literally cancel each other out.
So the wave just vanishes.
The physical wave is flattened. That is destructive interference. And when that flattened wave hits your laptop's antenna, the encoded data is completely corrupted.
Ah, because the packet header is unreadable, so the laptop just drops it and asks the router to start over.
Precisely. And if that happens 1,000 times a second, my Wi-Fi grinds to a halt, even if my device says I have full bars.
Wait, really? Even with full bars?
Yeah, because full bars usually just measure the raw amplitude of the energy reaching your device, not the quality of the data within it. Your device is basically shouting that it hears a very loud noise, but it cannot understand the words.
That makes so much sense.
And TMA's technology addresses this by reducing the interference itself, and the mechanism is right there in the name. Passive directivity enhancement.
Okay, let's break down the word passive in this context because, like, in RF engineering, doesn't an active solution usually mean injecting more power?
Usually, yes.
Like, if a signal is weak, you plug in an amplifier to just blast the signal out with more wattage?
Which is pretty much the worst possible way to solve an interference problem.
Why is that?
Think about it. If you amplify a signal in a crowded airspace, you are raising the noise floor for every other device in the vicinity.
Oh, right. You are just shouting louder into an already deafening room.
Exactly. Which just forces everyone else to shout even louder in response. It creates an escalating arms race of electromagnetic noise.
Nobody wins that fight.
Nobody. So a passive solution achieves the goal without requiring an external power source to brute force the signal.
So it relies on physical structure and geometry instead.
Yes. Think about the physical shape of a trumpet bell or an optical lens.
Okay, a lens.
The lens doesn't generate its own light, right? It takes the existing ambient light and passively bends the physical geometry of the waves to concentrate them into a focal point.
Right.
Passive directivity in RF technology applies a very similar philosophy to radio waves. Without adding chaotic, active noise to the environment, the structural design passively shapes the electromagnetic field.
So it focuses the radio frequency energy strictly where it needs to go, rather than bleeding it out in a giant 360-degree sphere.
Yes. And just as importantly, it works in reverse for the receiver.
What do you mean?
Well, a highly directional antenna design passively rejects signals coming from off-axis angles. It creates a narrow, focused corridor of communication.
So in the hospital, it means the receiver is mechanically deaf to the ambient noise of the ward, and it's listening only to the pacemaker.
You've got it.
And in my living room, it means my laptop and router can establish a focused corridor that naturally rejects the overlapping wavelengths coming from the microwave or the neighbor's apartment.
Exactly. By drastically reducing that destructive interference, the overall effectiveness of the system skyrockets.
Because the hardware isn't spending half its processing power discarding corrupted packets and requesting retransmissions.
Right. The data flow becomes heavily optimized. You essentially reclaim the actual bandwidth that the environmental noise was stealing from you.
It's just fascinating how a physical, geometric approach to managing waves scales across such wildly different applications.
It really is.
But, let's step out of the living room and the hospital ward for a second.
Okay, where to?
We need to look at the business graveyard.
Yeah.
Because history is littered with brilliant structural physics and theoretical miracles that never made it off the whiteboard.
Oh, absolutely. The gap between a functional laboratory prototype and a globally deployed product, that is where most innovations die.
Which brings us to the final two realities of TMA's technology from our notes today.
Right.
The innovation is patented and it is cost-effective. Now, these seem like incredibly dry business terms compared to, literally saving lives.
They do sound a bit dry, yeah.
But they are the actual mechanisms that dictate whether this technology sees the light of day. I always compare it to a secret family recipe.
Okay, how so?
Having the best recipe in the world doesn't matter if you can't afford the ingredients or if someone else just steals it and mass produces it before you can.
That's a very grounded way to look at it. And if we connect this to the bigger picture, those two attributes, patented and cost-effective, are exactly what allow a piece of advanced physics to survive the brutal realities of global supply chains and regulatory environments.
Let's look at the patent first. Because in the medical device industry, you can't just invent a better antenna in your garage and start putting it into pacemakers the next week.
The regulatory burden is immense, as it should be, honestly.
Oh, for sure.
Proving to regulatory bodies, like the FDA, that a new wireless mechanism is perfectly stable and will reliably save lives, that requires years of clinical trials.
And rigorous stress testing, I imagine.
Oh, rigorous isn't even the word. It's millions upon millions of dollars in research and development overhead.
And frankly, no company is going to spend a decade and tens of millions of dollars validating a technology if, the moment it hits the market, a massive conglomerate can just reverse engineer the geometry and mass produce it.
Exactly. The patent is the economic moat.
Right.
It provides the legal and financial security required to justify that staggering upfront investment. It protects the structural architecture of the directivity enhancement so that the creators actually own the solution they spent years validating.
So without the patent, the financial incentive to push this through the medical regulatory gauntlet simply disappears.
And the technology dies in the lab.
But the patent only solves half the economic equation, right? Because you can have the exclusive rights to manufacture a brilliant piece of technology, but if your manufacturing process is too complex or relies on incredibly rare materials, the unit economics will just fail.
That is exactly where the phrase cost-effective dictates the future of the technology.
Yeah.
It is the difference between building a bespoke, multi-million-dollar satellite component for an aerospace agency and engineering a part that can be reliably stamped out on a global assembly line.
Right. A specialized antenna array might work perfectly to isolate a signal, but you can't put a $5,000 RF component into a $50 home Wi-Fi router.
You really can't.
And you certainly can't integrate exorbitantly expensive materials into a pacemaker without drastically limiting the pool of patients and healthcare systems that can afford the life-saving procedure.
And being cost-effective in hardware engineering, it usually means the innovation can be manufactured using existing scaled fabrication techniques.
Okay, so they don't have to invent a new way to build things.
Right. It means TMA has figured out how to achieve this passive directivity enhancement without requiring exotic metamaterials or, completely overhauling how circuit boards and antennas are currently printed.
So it slots seamlessly into the existing manufacturing ecosystem.
Exactly. It scales. And because it scales, it allows the technology to be democratized.
That's huge.
When an innovation is both heavily protected by a patent and highly cost-effective to produce, it crosses the threshold from a theoretical physics paper into a viable global standard.
It becomes economically realistic for consumer electronics companies to adopt it by the millions.
Yes,
And
and for medical device manufacturers to integrate it into their critical care lifelines.
so what does this all mean? We've traced the impact of a single conceptual breakthrough, TMA's passive directivity enhancement technology.
Yeah, we've covered a lot of ground.
We started by looking at an environment where signal failure equals systemic failure. In a hospital, the hostile physical environment of lead, concrete, and competing frequencies constantly threatens to corrupt the data packets essential to a wireless pacemaker system.
And TMA's technology provides the structural stability needed to guarantee those signals arrive intact, literally saving lives.
And by unpacking the physics of how it achieves that stability by passively directing the signal and rejecting ambient noise, we see that the solution to medical telemetry failure is the exact same solution to home network congestion.
It's all connected. The physics of destructive interference are universal.
Yeah.
Whether it's a heartbeat anomaly or a video frame, overlapping waves destroy data.
And by shaping the electromagnetic field rather than just pumping more power into the room, this technology clears up the crowded airwaves, making everyday systems vastly more effective.
Right.
And it manages to do all of this while remaining patented to protect the R&D and cost-effective enough to actually be manufactured at scale.
It is a profound example of how identifying and solving the root physical mechanics of a problem, rather than just treating the symptoms with more active power, creates a ripple effect across entirely disparate industries
It's a structural upgrade to an invisible infrastructure that we completely take for granted.
until our screens freeze,
Right. Or far worse, a medical monitor goes dark.
which leaves a very compelling question to consider as we wrap up today's deep dive.
What's that?
Well, if a single passive geometric enhancement to our radio frequencies can fundamentally stabilize the devices keeping our hearts beating, while simultaneously fixing the networks keeping our daily lives connected,
Yeah.
what other invisible infrastructures in our daily lives, systems that govern our logistics, our power grids, our transportation, are currently fighting their own version of chaotic interference?
Oh, that's a fascinating thought.
What other foundational systems are just waiting for a similar structural enhancement to suddenly run with perfect clarity?
That is something to think about. Thank you for joining us on this deep dive. Keep looking closely at the invisible world around you, keep questioning the mechanics of how things work, and stay curious.